Hey, so we're taking a look today at the chemical reactions, your test review. So we're going to start at the very top, and it says, what are the products in this reaction? So we're going to look at reactants, what are your products, and then what do these little letters at the base represent? So the reactants are going to be the elements that are actually doing the reacting. So they become whatever's being combined on the left-hand side of your equation. So aluminum and hydrochloric acid are your reactants. Then we have this little arrow. That little arrow stands for yields or produces your products. So this is a new substance or compounds that have been produced in your chemical equation. The next thing it's asking about are what do these little letters underneath represent? So we're talking about the state that that element or compound is in. So S would be our solid, L would be my liquid. If you have a G, lowercase g is going to be your gas. And then we have this AQ. Well, AQ stands for aqueous. Aqueous means we have taken something and dissolved it in water. So AQ is aqueous, dissolved in water. The next thing is talking about on your sheet says that we need to balance. So because of conservation of mass, the beauty of this is that the number of atoms that you have on the left-hand side has to equal the number of atoms for each element on the right-hand side. So the first thing we're going to do is we're going to tally up how many you have of aluminums, hydrogens, and chlorines. So we'll do that first. As we talked about in class, you can make a column on the left and a column on the right, but for simplicity's sake, I'm going to go ahead and write it just straight down the middle because I know aluminum has to exist in equal amounts on both sides. So I have one aluminum, I have hydrogen, and a chlorine. Now, we talked about listing all of our metals first to make more complicated problems a little bit easier. So I'm going to list my metals, then if I had non-metals, then I'm going to have my hydrogen. So in this case, we're going to go out and count. I have one aluminum, one hydrogen, one chlorine. Not in that order, but one chlorine, one hydrogen. I have one aluminum, 3 chlorine, and 2 hydrogen. So the first look, we're only looking at, does this balance? The aluminum for 1 atom on each side. Chlorine, the 1 and the 3. Those should match, but they don't. So I have to have, if there's 3 over here that have been produced, that means I had to have started with 3 reactants for chlorine. The only thing we can adjust in a chemical reaction equation is a coefficient. So that is a large number that goes in front of the entire compound. I can't squeeze it in between. I have to go outside because that's already a compound. So now I'm going to cross this out and write 3. Feel free to erase to keep it clear, but this way you're going to be able to track your steps. If you think you've overshot and gone too far, you could always go back if you've left your work. So now I'm going to recount. I have 3 hydrogens, 3 chlorines. Well, that works for here, but now this is messed up, putting this coefficient in front of chlorine and hydrogen. Now I have 3 hydrogens, but only 2 on the product side. So now I'm going to have to look at what do I have in common between 2 and 3? Oh, 6. So if I have 6 hydrogens here, 6 hydrogens there, my factor here would be, saying 3 times 2. So I come over here, what times 2 is going to give me 6? That was 3. Now I have a 3 here, but I need 6. So we're going to erase and put 6. Now, why have I done that? Because I ended up with factors between 2 and 3, and what they had in common was 6. So now I have 6 hydrogens and 6 hydrogens on my product side. So I go back, what has that impacted? Well, now I have 6 hydrogens, yes, but my chlorine are 3. So how am I going to make that 6? It's already 6 because you distribute here, but over here I only have 3 chlorines. So now I'm going to multiply by 2 because that is the only way I can adjust the number of chlorines is by putting a large coefficient in front. So now that's 2 times 3 gives me 6 chlorine. So if we look at our entire equation, I now have 1 aluminum here. Oh, now I have 2 aluminums. So if I know I have 2 aluminums on the right-hand side, I'm going to have to come back. What can I do to make that a 2? Simply put a large coefficient in front, or a large 2. A large number that goes in front, that's my coefficient. So I have 2 aluminum, 2 aluminum. Check. They're both balanced. Now, they don't have to balance vertically. I'm only balancing this element. So 2 and 2 is matched. We're good to go. 6 hydrogen, 6 hydrogen. 3 times 2 is 6. So my hydrogen are good. Chlorine, 6. Chlorine, yes. And chlorine over here, 2 times 3 gave me 6 chlorine. So all 3 of those have been balanced.